Some people blame climate change. Others blame poor city planning. Politicians point fingers at outdated infrastructure. Engineers argue over which dam needs to be rebuilt first. But here's what almost nobody is talking about. The real reason the Netherlands is losing its battle against the water has nothing to do with what's coming over the walls. It's what's happening underneath them. Right now, while you're watching this, 17 million people are living on land that physically should not exist. Cities perched 7 meters below sea level, ships sailing above rooftops. A country where, if a single network of pumps stopped running for 24 hours, entire districts would flood by morning. And for decades, the world has looked at the Netherlands and said, they figured it out. The tallest sea walls, the most advanced storm barriers, the most sophisticated flood engineering on the planet. But the engineers themselves will tell you something different. They're not winning, they're running. To understand why the real threat is invisible, you first need to understand how spectacular the visible defense actually is. Stand at the mouth of the Rotterdam harbor on a stormy night, and you will witness something that feels more like science fiction than civil engineering. When North Sea waves breach 3 meters, an automated computer system, no human approval required, triggers the largest movable structures ever built by human hands. 2 curved steel arms, each one as long as the Eiffel Tower laid on its side, begin sliding out of their concrete housings on either side of the waterway. They move slowly, deliberately, the way something moves when it weighs hundreds of thousands of tons. When the 2 arms meet in the center of the channel, valves inside the steel open and seawater floods into the hollow cavities. The weight becomes monstrous. The entire structure sinks to the riverbed, pressing itself against the stone foundation with a force that makes the ground tremble. This is the Maeslantkering, the final lock between Rotterdam, the largest port in Europe, and the North Sea. And it is only one piece of a system so vast it took 45 years and billions of dollars to complete. The Delta Works, a chain of dams, sluices, storm barriers, and dikes stretching across the entire southwestern coast of the Netherlands. When the project began in the aftermath of the catastrophic 1953 floods that killed nearly 2,000 people in a single night, the goal was audacious: shorten the coastline by hundreds of kilometers, so the sea simply had fewer opportunities to break through. It worked. For decades, the Netherlands became the global authority on flood protection. Engineers from Bangladesh, New Orleans, Jakarta, anywhere water threatened human civilization, flew to the Netherlands to study how it was done. And the Dutch told them, build higher walls. That was the right answer. For a while. The story that everyone tells about the Netherlands goes like this. The sea is rising. Glaciers are melting. Storms are getting stronger and more frequent. The walls that protected Dutch cities in 1980 won't be tall enough in 2050. So the solution is obvious. Build the walls higher. Reinforce the dikes. Upgrade the barriers. Pump more water out. This narrative makes sense. It's clean. It has a villain, climate change, and a solution, engineering. And it is absolutely real. Sea levels along the Dutch coast are projected to rise significantly over the coming decades. The storm surge events that once happened every few centuries are now expected every few decades. The Maeslantkering, designed to close a handful of times per year, may need to close hundreds of times per year by mid-century. So governments fund bigger barriers, taller dikes, more powerful pumps. The world watches and nods. The engineers take the money and start building. And the ground keeps sinking. Here is what actually created the Netherlands as we know it. 1,000 years ago, this land was a massive, rotting swamp. Rivers constantly shifted course. The coastline was soft as wet sponge. When tides rose, the ocean pushed dozens of kilometers inland, turning fields into salt lakes overnight. The first settlers built their homes on artificial earthen mounds and simply waited for the water to retreat. But the population grew, and there was never enough high ground. So they did something that had never been done at this scale before. They surrounded the swamps with rings of earthen dikes, then used windmills, hundreds of them, running day and night, to pump all the water out. The land that appeared from beneath the drained water is called a polder, and polders are everywhere in the Netherlands. They are farms, they are city centers, they are highways and airports and neighborhoods where millions of people wake up every morning and drink their coffee and go to work. And here is the trap buried inside every single one of them. The moment you pump water out of marshy soil, the soil begins to dry, and as it dries, it compresses, it shrinks, like a sponge that someone is slowly squeezing. The Dutch drained the land to save it, and in doing so, they caused it to sink. Every polder they created made the ground lower, which meant they needed to pump harder to keep the water out, which dried the soil further, which caused it to sink more. A perfect loop with no exit. Today, some parts of the Netherlands are not just below sea level, they are actively sinking at rates of up to 10 millimeters per year. The cities aren't stable. They are in slow, continuous freefall. And this is only the first half of the real story. While every camera focuses on the storm barriers and every political speech celebrates the dikes, something else is happening in total silence, deep underground. It's called the salt wedge. As the Dutch pump fresh water out of the soil to keep the polders drained, they create empty space, microscopic voids in the earth. And the ocean, as it always does, finds a way in. Seawater doesn't just attack from above. It seeps laterally through porous sand and sediment. It infiltrates aquifers. It moves inland, not in waves you can see and film and point at, but in a slow, invisible pressure front that advances meter by meter beneath roads and buildings and farmland. When salt water displaces fresh water underground, two things happen. First, the agricultural economy begins to collapse. Dutch farms are among the most productive on the planet, but they depend on precise groundwater management. The moment salinity levels in the soil cross certain thresholds, crops fail, roots rot, fields that fed Europe for centuries turn barren. Second, and more disturbing, the freshwater supply is threatened from below. Cities tap into underground aquifers for drinking water. If the salt wedge reaches those aquifers, no amount of barrier construction fixes the problem. The water flowing from taps becomes undrinkable. Here is the terrible paradox this creates. The more the Dutch pump water out to prevent surface flooding, the more space they create for salt water to infiltrate underground. The very act of defending against one form of water invasion accelerates another. To fight back, engineers pump fresh water back into the ground in strategic locations, creating an invisible freshwater barrier to block the advancing salt. It is an absurdist engineering battle fought in total darkness, kilometers underground, where no camera can go and no wall can help. And it does not have a permanent solution. There is one more layer to this, and it is the one that keeps Dutch scientists awake at night. The soil beneath the Netherlands does not behave like solid ground. It behaves like thick gelatin. It flexes. It breathes. It shifts under pressure in ways that models only partially predict. As sea levels rise, the pressure on underground sediment layers changes. Areas of land that seemed perfectly stable begin to flex or sink in unexpected locations. Not along the coast, sometimes 50, 80, 100 kilometers inland. The foundations of century-old buildings in Amsterdam develop new cracks. Roads that were perfectly level last year develop subtle undulations. Sensors in monitoring wells record saltwater advancing in patterns that contradict the previous week's model. The Dutch have responded with increasingly creative engineering. Artificial sand islands constructed offshore to redirect underwater currents. Experimental deep injection systems to stabilize collapsing sediment layers. New building codes requiring all structures to rest on pilings driven to bedrock, because any foundation that stops short of bedrock will, eventually, tilt. Every house in Amsterdam sits on wooden pilings driven into the mud. Some of those pilings are 400 years old. As long as they stay submerged in groundwater, the wood holds. The moment groundwater levels fluctuate, which they increasingly do, due to all that pumping, the tops of the pilings dry out. They begin to rot. Buildings that have stood since the 1600s start to lean and crack. Not from a flood, not from a storm, from management decisions made in pump stations you've never heard of, run by technicians whose names you'll never know. So let's be direct about what the Netherlands is facing. It is not simply a country that needs taller walls. It is a country whose ground is sinking while the sea is rising, a compression from both directions that no single engineering solution can address. It is a country where defending against surface water accelerates underground infiltration, where pumping out rainwater destroys the foundations of buildings, where keeping farms productive depletes the aquifers that keep cities alive. Every solution creates a new problem. Every problem demands a new solution. And the financial cost of staying in this loop is staggering. The Netherlands spends billions annually just to maintain the current situation, not to improve it, not to gain ground, but simply to remain where it is. Every Dutch resident pays a mandatory water tax, not for new infrastructure, for maintenance of what already exists. And even that is no longer enough. New projections from 2025 and 2026 show that several coastal protection systems are operating closer to their design limits than previously thought. Not because they were built poorly, but because the ground they're anchored to has moved. A seawall designed to sit on stable bedrock is only as good as the bedrock itself. The question the Netherlands is now asking, the question engineers around the world are watching with barely concealed anxiety, is whether there is a point at which the control loop breaks. Not in a single catastrophic event, but in a slow cascade of individually manageable problems that eventually overwhelm the system's capacity to adapt. The 1953 flood killed 1,800 people in one night because a storm caught a sleeping country unprepared. The scenario Dutch engineers fear today is quieter, slower, and in many ways harder to fight. A country that is perfectly awake, perfectly prepared, running every pump and sensor and monitoring system at full capacity, and still losing ground. There is a reason the Netherlands has become the world's leading exporter of water management expertise. It is not because they solved the problem. It is because they have been living inside the problem longer than anyone else. When Jakarta needs to stop sinking, they call the Dutch. When Houston needs to rethink storm drainage, they call the Dutch. When Miami starts worrying about what happens to a coastal city when the groundwater table rises, they call the Dutch. And what the Dutch have learned, the real export, the knowledge that no other country has earned through the same depth of experience, is this. You cannot defeat water. You can only negotiate with it, indefinitely, at enormous cost, with total attention. The moment you think you've won is the moment the ground shifts beneath your feet. For every other coastal city on Earth, New York, Shanghai, Mumbai, London, Bangkok, this is not a cautionary tale about a small European country. It is a preview. The Netherlands is not a curiosity. It is a clock. And right now, that clock is telling the rest of the world exactly what time it is. The question isn't whether other cities will face what the Dutch face. The question is whether they'll be honest enough to look. If you want to understand what's quietly happening beneath the world's most famous cities, from Tokyo's vanishing coastline to the invisible crisis under New Orleans, subscribe. There are stories ahead that will change how you read a map.